Hello everyone. Today I am going to start discussing about z-score, normal table, and sampling distributions. These three things. So let me open a Word file. This is the Word file. Let me insert few pages. I think enough pages has been entered. Let me go do some things. We are going to learn today z-scores. Z-scores, normal table, and sampling distribution. Sampling distribution. Okay, sampling distribution. So remember last class I discussed about empirical rule. Let me write it in here. I discussed about empirical rule. Empirical rule. Now in the empirical rule, what we did if we have a quantitative variable, and if quantitative variable, if we construct the histogram and add the top middle point of the each bar, then within one standard deviation from mean, suppose this is my mean, which is x bar, okay? Within one standard deviation from mean, like this, x bar plus s, within one standard deviation from mean, x bar minus s. In this part, 68% of the frequency fall. In this part, 68% of the frequency fall. And within two standard deviation, x bar minus twice s and x bar plus twice s, x bar plus twice s, 95% data fall. 95% data fall. So in this case, 95% data fall, 95% frequency fall. Within three standard deviations from mean, x bar minus 3s and x bar plus 3s, 99.7% data fall. 99.7% data fall. Okay. Now, these are in the X scale. These are in the X scale. X scale. So are you saying X scale? Like, so data is given in the X format. So X format means suppose Xi is the data which take values like 20, 25, 29, 30, 41, 40, 60, 65, 29, 30, 25, 42, 49, 50, 29, 27, 32, 35, 46, 49. So suppose x's are in this format, and also suppose these x follow normal distributions. This x, if we plot this follow symmetric bell-shaped or mound-shaped. So this is the distributions of this x, and here is the x bar. Here is the x bar. The x bar is the mean of this data. X bar is the mean of this data. Here is the x bar, this is the data. So, and in such a cases, if they follow normal distributions, then empirical rule will apply, which is within one standard deviation, 68%, within two standard deviation, 95% within 3 standard deviation, 99.7%. Okay. Now data is given in the X format. If data is given in the X format, then if we create like this, Z equal to X minus mean, which is mu, divided it by sigma, which is standard deviations. So mu is the mean of X data, mean of X, and sigma is the standard deviation of X. So I have the data. Let me open an R and see whether any data is in there. Suppose I have these data. I have this data, empty cars, $sign MPG. So this is my data. Okay. This is my X. In this AX, I can compute mean, which is equal to, let me write here average, ABG, ABG average, which I can compute mean as a empty cars, $sign MPG, and then I got like this, and I can compute standard deviation, STD, standard deviation I can compute, which is equal to SD, and then empty cars, $sign MPG, then I have this. So now what is Z? Z equal to, if I do these things, Z equal to, it could be like, I can write here, empty cars, $sign MPG minus ABG divided by STD, and then Z is not defined properly. If I write like this way, then this is what I have Z. This is my Z. Are you saying Z means if you subtract the mean of the X, mean of this X, which I just showed you, and standard deviation of X, then you will get this. This is called the Z score. Now, within 3 standard deviation, in such a cases, Z has a mean 0 and standard deviation 1. Previously, here is X and mean is X bar, right? Now, here is the mean. It is in the Z scale. Now, it is in the Z scale. Mean equal to 0 and standard deviation sigma or S equal to 1. Now, let me rephrase these things. Let me rephrase this thing. X has a mean of mu or X bar if you write, and X has a standard deviation sigma or known as S, because here is the sigma is for the population and S for the sample. We computed it from the sample, so that is why S. Now Z has a mean, 0 and Z has a standard deviation of 1. So notationally, how can I write it? Notationally, I can write it X follow normal distribution with mean, mu, and standard deviation sigma. Notationally, I can write Z follow normal distribution with mean 0 and standard deviation 1. Okay. This is the Z score. So now you have understand what is Z. What is Z? Suppose if your X follow normal distribution, so that means the quantitative variable X, if you construct histogram at top middle point of each bar and then get the frequency curve which looks like symmetric bell shape, mount shape, then X follow normal distribution. What do you mean by x follow normal distribution? X is a quantitative variable. You constructed histogram and you add top middle point of the each bar, and the curve that you obtain looks symmetric, bell shaped or mound shaped, and then you will call that x follow normal distributions. In that normal distributions, if you create a new variable z where x is your original variable and subtract the mean of x, divided it by sigma, then z is called, then the new variable is called the z, and z is called standard normal variable. Standard normal variable. Z is called standard normal variable. X is called just normal variable. Okay, x is called normal variable. Now x is called normal variable, z is called standard normal variable. Now let me write it. And z has this type of now probability function. Probability, let me write it. Probability density function. Probability density function could be written as f x mu and sigma. This is the mathematical format of normal distribution. I'm just writing it. You do not need to memorize it. You do not need to use these things in the exam or homework. Okay. So this is just the mathematical expressions for the probability distributions of the normal variable. This is called a normal distributions. Probability density function of the normal distribution. This is the x. What is the z? Z has like this 1 over twice pi and sigma equal to 1. So it has 1 minus 2 z square. So this part, you remember this part is the z. Let me take a note it in here. This part is the z. This part is the z square, okay? Because z equal to what? Z equal to x minus mu over sigma, okay? And then there is a square, so that man is this. So this is the probability density function of the standard normal distributions. Now, if you have a data, from that data, if you find the distribution of x bar, how x bar behave, then this is called the sampling distribution. Probability of x bar, it has a mean mu and standard deviation sigma over square root of n. It is written 1 over twice phi sigma over square root of n, and it is n minus 2 sigma square and then x bar minus mu square. So this distribution is called the sampling distribution. This is called the sampling distribution. So in the next, again, let me tell you, you do not need to memorize these things, or you would not have to write these things in the exam or quiz or anything. I just want to tell you how the mathematical formula for the normal distribution looks like. That is why I write this equation. How the mathematical formula of probability density function of standard normal variate z looks like. So that's the reason I write this. And this is the sampling distributions mathematical formula. So this is the probability density function of X bar, which is sampling distributions. Now, in the following few um, uh, moments, I'm going to show the applications of these distributions. Okay, let me start with the Z. Okay, so I want to find probability of Z less than 1.21. Probability of Z less than 1.21. In order to do that, this is the number one problem. So I have to draw the figure. This is the figure. This is the figure. The figure drawing may not be good. I want to compute it in here. Suppose this is 1.21. I want to find this area, this proportion or percentage of frequency that fall in here. Z less than 1.21. Z less than 1.21. How can I find that? There is a normal distributions. I want to open that one. Normal table. Okay, normal table. What did I say? So I can save it somewhere. 1.21, right? 1.21. 1.21. Take a look at that. 1.21. So 1.2, and then if you add this 1.21, 8869. 8869. So answer is 8869.8869. How can I compute it by using R? So let me show you how to compute it by using R. P norm 1.21, mean equal to 0, standard deviation equal to 1, and then I got 8869. Okay, you have seen that I have computed these things. So the formula is P norm. R formula I am writing in here, P norm 1.21, 0 and 1. Now I want to write the Excel formula. Let me open the Excel. Is there any Excel open? Yeah. So let me go there. I want to write here norm distribution norms. I think norms distribution 1. If you want to put this, and then if I want to put here X mean Y. Okay, so it is 1.21, mean equal to 0 and standard deviation equal to 1. And then if I write it, enter a few more arguments for these situations. 1.1 mean and cumulative. Okay, I have to put here 1 Q mu. Oh my goodness, cumulative. Cumulative. Okay, why? 1.21 cumulative. X mean equal to 0, standard deviation equal to 1, cumulative. Norm dot dist. Let me see. Norm dot It turns the standard has a mean 0, standard deviation of 1. Z 1.21, comma, true. Okay, so take a look at that. So it's sorry for taking long time. So for the standard normal distributions, you have to use these things. Let me write it. How to use in uh, Excel. In the Excel, you have to write it in here. You have to write here norm dot s dot distribution, then 1.21 and true. If you write this, you will get same 8869. Okay, 8869. So if I write it in here, write this, then see what I'm getting. Norm dot s dot distribution 1.21. Okay, so I have shown you how to compute these things by using Excel as well as R. Now I want to do the second one. Second one I want to do probability of z less than negative 1.46. Okay, in order to do that, we should do these things. Negative 1.46. So this is what I want to find. Okay, in order to find this, what I have to do in R, if I write it in here, p norm, I have to write here p norm. This is n, p norm negative 1.46, 0, 1, or in Excel, I want to write here norm dot s dot distribution, and then I have to write here negative 1.46 true. Okay, let me try here. Norms negative 1.46. negative 1.4646 true. If you put it in there and hit enter, you will get 0.07. 0.07, and then if you use here R, then you have to write here P norm negative 1.46. Then you have negative like this. Okay, so I have given you two example of this. Now you can compute these things. What happened? So now you can, number 3, you can compute probability of Z greater than 1.41, which you can compute 1 minus probability of Z less than 1.41. That means you are asked to compute these things. You are asked to compute these things. 1.41, 1.41. You are asked to compute these things, which you can do. And Excel and R code, you just put here 1 minus, either put here Excel code or put here R code. So then you will get it. Similarly, you can do number 4, probability of Z greater than negative 1.5. Let me put here 2.56. 2.56, which you can do 1 minus probability of Z less than negative 2.56. Okay, you can compute these things very easily. So just plug 1 minus, this is your R code or Excel code. If you put, you can compute these things. If you do not like coding, then you have to use the table that I have showed you. This is the table that I have showed you. You have to take help from there. Okay, after these things, now I want to move for another type of problem. I want to do now 5, probability of Z between 3 and 2. This is what I want to do. How can you do that? 3 and 2. You can do this by writing these things. This is 0. This is your 2. And this is your 3. Okay, so now you can do like this. You can do these things. These things you can do. Probability of Z less than 3 minus probability of Z less than 2. Okay, so that means you are getting these things here. You can write the R or Python, R or Excel code. Here you can write R or Excel code. You will get your results. So now you can also do 6 number, probability of Z less than negative 2 less than negative 3, which you can do probability of Z less than negative 2 minus probability of Z less than negative 3. Okay, so you can now plug their Excel code or R code in order to get this value. Okay, after doing this, now you can find 7, probability of Z between 3 and negative 1. Which is this? Z between 3 and negative 1. Z between 3 and negative 1. 3 and negative 1. So this is what you can easily find by using the Excel or R code. Z less than 3 minus Z less than 1. Okay. Now you can put here Excel code. You can put here Excel code or R code. So now the 7 problem has been gone. We have put greater than, less than, between. These 7 problem are greater than problem. These 7 problem involve greater than, less than, and between. Between, like this, x between these two, the above 7 problem. Now I want to solve another problem, like probability of absolute z greater than 1.62. How can I find this? Okay. Now, in order to explain these things, let me explain this. Suppose z, absolute z greater than 1. Suppose absolute z greater than 1. Okay. What does this mean? I want to take out this absolute sign. If if you take out this absolute sign, then it will mean, suppose this is what I have, this is equal to 0, and this is equal to 1, and this is equal to -1. When you take out the absolute sign, then you have to write z greater than 1 plus z less than -1. So that means if you take out this absolute sign, you do not know whether it is positive or negative, right? So that means you have to consider you are computing this part and you are computing that part. Okay, absolute g greater than 1, when you take out absolute sign, then you will have this. Now you have to write here probability of z greater than 1.62 plus probability of z less than -1.62. This is what you are finding. When there is absolute z and when you take out the absolute sign, then you will have these things. You have to find these two things. Okay, you have to find these two things. You have to find these two things. Now, in order to, now this is easy, right? To find these things, it is easy. So what you can do, 1 minus probability of z less than 1.62, right? So this is equal to that. This is equal to that. Now you can find this using Excel or R, and then this is less than is, you can easily find it. Okay, remember, in order to compute this greater than or between, you will always have to go to the less than, otherwise you cannot compute. So the probability values are given in the less than format. So take a look at that. This is given in the less than format from here all the way. So this is the value less than 0.57. 0.57, that means this is. So the value is given from that point to all the way to the left. Take a look. The previously everything I transfer it to the less than. Let me start in here. So it is greater than, but I transfer it to the less than. It is greater than by, but I transfer it to the 1 minus less than. It is between, but I transfer it to the less than, between two less than. So every probability computations that are asked, you have to compute it by less than. Okay. So absolute. So absolute, this is now I want to put 8, 9, problem number 9, probability of absolute z is less than 2.1. How can I do that? So if z less than 2, the meaning of this z less than 2 means if this is the place where z equal to 0. This is the place where z equal to 2. This is the place where z equal to -2. And less than 2, that means z is less than 2 and less than -2. So that means this is what you are trying to finding. This is what you are trying to find. Okay. This is what you are trying to find. So now probability of absolute z. Yes, pa, pani now. Okay. Here, probability of z less than 2.1. Probability of z less than 2.1. So these things could be written as probability of z less than 2.1 less than negative 2.1. Okay. Now, if you want to write it like this way, and this is the result. So this is what we can compute. Okay, this is what we can compute by using. Now you can easily compute it probability of z less than 2.1 minus probability of z less than negative 2.1. Okay, now you can easily compute this. Now you can easily compute these things. Okay, after doing these things, greater than, less than, between, everything is done. Now I want to find the inverse problem. Inverse problem. Inverse problem. Okay, what is inverse problem? Inverse problem is now probability is given. I want to find the value of a. Z less than a equal to 0.29. So that means what? Let me explain this. 0.29, right? Here is z equal to 0, and here is equal to a, and this equal to 0.29. This equal to 0.29. How can I find these things? Okay, so let me find you manually by using the graph. 0.29. 0.29 come in here. 0.29. 0.29. 0.29. This is the closest of 0.29. Yeah, this is the closest of 0.29. So closest of 0.29 is this 0.2912 to 0.2877. Between these two, this is the closest one. So you can write a negative 5.5. 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. 0.55. So this is negative 0.55, negative 0.55, negative 0.55. So come in here, negative 0.55. So this is equal to negative 0.55. A equal to what? A equal to negative 0.55. Okay. A equal to negative 0.55. It after doing this, now suppose you are asked, so find the a, absolute a less than absolute z less than equal to 0.64. Okay, how can you find this? A equal to what? Okay, this could be your homework. Okay, or maybe you are given absolute z greater than equal to a equal to 0.60. Tell me what is a. This is your homework. Okay. After these discussions, now I will go for the x. X. So how can I solve the problem in the x? Suppose I want to write a problem. Write a problem and then solve it. Problem. SAT scores are normally distributed, normally distributed with mean 550 and standard deviation 50, then Find the probability that. Then find the probability that a randomly selected student has a SAT scores number 1 greater than 610, less than 560, between 560 and 590. Number 4, also find the SAT scores of that students so that it is in the 92nd percentile. It is in the 92nd percentile. Okay, now, first of all, X is the SAT scores. Okay, mean of X, that means X bar is given, that means mu is given as 550 and sigma is given, I think 50. Okay, so now first problem they are asking SAT score X greater than 610, X greater than 610. Okay, now I want to give a pause in there. I can directly do these things just by writing these things. 1 minus probability of X less equal to 610. I can directly do this, or I can transfer it to the Z and then do it by using Z. Okay, let me do it by using Z. X equal to X greater than 610, right? Now X minus mu divided by sigma 610 minus 550 divided by 50. Okay. Now this is my Z as I mentioned before. Then this is equal to 60 divided by 50. So that means 6 over 5. 6 over 5 could be written as Z greater than 0.30, right? No, 1 and then 10, 1.2, 1.20. This is. Now, these things could be done as probability of Z greater than 1.20. These things could be written like this way, okay? Because I transfer it in that format. So now 1 minus probability of Z less than 1.20. Now you can use the Excel or R formula in there and compute the probability that a randomly chosen student would have SAT score greater than 610. Okay. Another approach is just directly computing these things by using R and Excel formula. In this case, what you can do, 1 minus P norm, 1 minus P norm, 610, okay, 550, comma 50, then you will get the result. How? I can go to the R, 1 minus P norm, 610, comma 550, comma 50, then you can get directly. This is 0.1150. Okay, 0.1150, which is 0.115. Let me see, what did I find? 0.1150. So that is equal to point. I computed these things directly, 0.1150. Okay, I directly computed these things. Now, if I am asked to compute these things by using Excel, how can I do those things? Let me compute these things by using Excel. In order to compute those things by using Excel 610, here is the thing. I want to do this norm dist, norm dist, and then I want to put here 610, 610, and then I want to put here mean equal to 550 and standard deviation equal to 50, and then cumulative I have to put here 3 are you true, and then I finish this, and now I want to come in here 1 minus this. Now you will see the results is 0.11507. See what this is the formula, okay? 11507, 11507. Both R and Excel give us same result, 11507, 11507 or 1150. So this is the approximation problem. So that is why you got this thing. So here you will write 1 minus norm dot dist, norm. This is norm dot dist, and then you write here 610, and then you write here 550, and then you write here 50, then you write here true. Then you will get the result. Sorry for bad handwriting, but this is what, let me show you. 1 minus norm dist 610, 550 like this. Okay. Now, similarly, this less than problem, you can solve it less than problem, which is like this: probability of X, that means SAT score, less than, here X means SAT score, okay? Here I put here X what? SAT score. I clearly wrote here X less than 560, X less than 560. These things you can directly do these things in you can write here in R P norm, and then 560, and then you can put here 550, and then you put here 50 P norm. Or you can Excel, you can just put here norm dot dist, 560, and then 550, and then 50, and then true, true, true. Then you will get it. Okay. And now you can write here probability of X less than 560 and 590, 560 and 590. 590, and then 560. Similarly, you can put here probability of x less than 590 minus probability of x less than 560, so that you can easily compute it as a p-norm, p-norm 590, 550, and then 50 minus p-norm 560, 550, and then 50. Okay. So now this is the third problem. Now, fourth problem, I want to find the ACT score so that it is in the 92nd percentile. Okay, 92nd percentile. So I want to find the ACT score X, so that it is in the 92nd percentile. Okay. How can I do that? In order to do that, you just write the Excel code 92nd percentile. What is the value of A? Here, these things are given. .92. Okay. This is what we can, we have to find this. So in order to find A, the most easiest and shortcut procedure is that A, and then you could write here Q norm in R. Q norm, and then you put here 0.92, and then you put here 550, and then you put here 50. You will get the result. In Excel, you have to put here, come here, norm inf, and then you put here probability 0.92, and then our mean equal to 550, standard deviation equal to 50, and you will hit enter, you will get 620, 620.24. So you will get 620.24. So let me write here 620.24, and the action formula is norm dot inf, and then 0.92550 and 50. This is what Excel formula. Excel formula norm dot inverse, And now if I want to compute by using R, I have to put here Q norm, and then 0.92, and then 550, and then 50. If I write it, so 620. So I have shown you how to compute both, uh, using Excel and R. Okay. Now, finally, I want to solve another sampling distribution problem. That means X bar problem, X bar. Okay. So X bar problem. Now I am going to solve sampling distributions problem, or sampling distributions problem. Now, suppose 25 students took SCT exam from Hattiesburg High School. Find the probability that find the probability that average SAT scores of the 25 students exceed 595. Number two, average SAT scores of the 25 students is less than 600. Total SAT scores of the 25 students is greater than 550. 30,000. Greater than 30,000. Greater than 30,000. Okay, let me solve number one. Number one, what says? Average SAT score greater than 595. 595, right? See, how can you do that? You have to do this 1 minus probability of x bar less than 595, which is 1 minus p norm 595 and 55 standard deviations 50 divided by square root of 25. So that is the only place you have to change. And or if you want to do it, 1 minus norm norm dot dist norm dot dist. This is R and this is Excel 550 50 over square root of 25. Okay, so this is by Excel and this is by using R code. Number two, x bar less than x bar less than less than 600, less than 600, which you can do p norm 600 550 50 over square root of 25. P norm or you can write norm dot dists 600 550 50 over square root of 25. Norm dot dists, that is the way. And then finally, problem number 3, probability of sum of xi greater than 30,000. Greater than 30,000. So greater than 30,000 means probability of sum of xi divided by x and greater than 30,000 divided by 25. Okay. So now it become probability of x bar 30,000 divided by 25. 30,000 divided by 25 will give us 1200. Will give us 1200. Alright. So 1 minus probability of x bar less than 1200. So 1 minus you can put here. Okay, instead of 30,000, let us put here. Let us put here 20,000. If I put here 20,000, then 8. Let me put here 18,000. Okay. So let me put here instead of 30,000, instead of 30,000, instead of 30,000, let me put here 15,000. 15,000. And then 15,000 divided by 25 will make 600. So that is equal to 600 less than 600. Now you can put right here P norm 600, 550, and then 50 over square root of 25, which you can get here 1 minus P norm 600 by 550, 50 over square root of 25. So this is the result. Um, very small probability. Okay. So this is like very close to 0. So very close to 0, something like that. Let me see how many. 6 zeros, 1, 2, 3, 6 zeros and 7. So that is the answer. So that is all about, this is all about this is all about z-score, normal distribution and sampling distributions.